Okay, so we're going to look at the unit circle in this video, and then we'll do trig equations maybe in next video or in a later video. So unit circle is the circle that has a radius of 1 unit, okay, as it says, I suppose. And with the unit circle, what we think of is we think of it as being placed on the coordinate axes. So kind of what you can see in the diagram there. And the center of the circle here is the origin, 0, 0. So for any point on the circle, we can rewrite that as an xy coordinate. Okay, so if we think about where coordinates come from, the x coordinate refers to how far across the x-axis I have to go to get to it, and the y value then refers to, again, how far then I go across the y-axis to get to it. And if we mark that in there, what we can see is formed is a nice triangle with our radius of 1. By doing that, we're able to rewrite our point P using that angle that we have in the center. We can see that angle theta there. So we're able to rewrite it using our cos theta and our sine theta. How that comes about is if we think about what cos means, that's our adjacent side over our hypotenuse. For this, our adjacent side is x, our hypotenuse is y, so we get that cos theta is equal to x. And then similarly with sine, sine is opposite over hypotenuse, so sine theta will be y over 1, so sine theta is simply equal to y. So I can rewrite my point P then as just cos theta sine theta. So for any point on the circle, if I pick any point on the circle, say I picked another point here, Q, that point could be rewritten as cos theta sine theta for whatever the angle is, theta there that I've kind of marked in orange. So the angle from the axis, the horizontal axis, up to that point, as if I've taken the point from here and kind of pulled it round until I got to Q, and see what angle my radius makes with that point. Okay, so that's kind of where it's all coming from, I suppose. And with our unit circle, there's something in particular that we have to look at, and that's the 4 quadrants. So we can divide it up into 4 different sections or quadrants, and in each of these quadrants, our ratios will either be positive or negative. Okay, and by ratios, we mean our sine and our cos and our tan. And to remember which is which, we use what we call the cast circle. And this is the cast circle here. So you can see we start with the C kind of down in this bottom quadrant here, and that's actually the 4th quadrant. In the 1st quadrant, which is this one here, the 1st quadrant, all of our ratios are positive. That's what the A stands for, so they're all positive. And that's angles between 0 and 90 degrees. So remember, we're looking at a circle, and we always kind of start from this point here in terms of the angles. So if I go here, I've made an angle of maybe about 45 degrees. If I was to draw kind of my line up to it, so around about 45 degrees. If I go up to the first kind of where we would see the top of the y-axis here, I've made an angle of 90 degrees. Continuing round, I go up in kind of my 90s for each section or each quadrant. So in the 1st quadrant, they're all positive, and that's the one that we're used to working with, our angles between 0 and 90. Then between 90 and 100, when we're in the S section, sine is positive. The S stands for sine, the other 2 are negative. In the 3rd quadrant, the T stands for tan, so tan is positive, the other 2 are negative. And finally then in the 4th quadrant, cos, the C stands for cosine, so cosine is positive, the other 2 then are negative. So the only one where they're all positive is that 1st quadrant, the top right. And remember that that's your angles between 0 and 90. So we're used to working with those angles, and we kind of expect our answer to be positive there. If we were to take a second maybe to just think about where this comes from, to get that kind of understanding of why are they positive or why are they negative. If I was to pick another point here, and I want a point that's going to kind of mirror image my point P. Okay, so I'm going to pick another point over here, we'll maybe call it Q, and Q is going to be a mirror image of P. So I want the x and the y coordinate to be essentially the same. I just want it to be a mirror image just on the other side. Now what we should notice here is that if I'm looking at the x value, I'm going across the same amount as I did with P, but I'm going over in the other section. Okay, I'm going to the left hand side from the origin. And what we should know is that if I go that way, all my x values will be negative. So I'll have the same answer. I'm going across the same amount. So for example, if I went across 2 to get to P, if this was 2, then what we're saying is that this one here, my x coordinate for Q, is going to be -2. That's what we're getting at. So I'm going over the left hand side, so instead of my coordinate being positive, my coordinate's going to be negative this time. The y coordinate, however, will still be positive, because I'm still in my positive section of the y-axis. Okay, if we think about the y values along this axis, they're all still positive. So my point Q now is going to be -xy. Now thinking about what we did already when we looked at the different sectors before, when we looked at renaming our coordinates, we can do something similar here. So I've drawn in the same angle in the same way we did with P, putting it again to the horizontal so that I can make a nice kind of clear triangle. I already have the 2 sides, so I'm just marking in the last side. We already know that our radius is still 1 because it's still the unit circle. So if I was to try and get cosine, for example, cosine theta is my adjacent side over my hypotenuse. My adjacent side now is -x over 1. So my cosine theta is going to be -x, which is a negative value. Okay, so cosine is negative. Okay, what about if we try tan? We didn't actually try tan in the previous section, but what if we try to look for tan theta? Tan theta is my opposite, which is y, over my adjacent, which is -x. So tan theta is minus y over x, or y over -x, but altogether it's going to, again, be negative. So tan is negative. And if we try then about sine, sine of theta is my opposite, which is y over 1. So sine theta is just y. And that's actually going to be positive. Now, if we were to compare to the cast circle that we just looked at, up in that quadrant, in my second quadrant, which of my ratios is positive? We said sine was positive. And this is why. Okay, sine is positive in that quadrant because the y value that we're looking at for that coordinate is positive. So when we kind of construct it in the same way that we did with the previous one, even though we've kind of copied the point P and done kind of a mirror image, we said our x value was going to be negative this time because I've gone the other way on the x-axis, but the y value would still be positive. So cosine and tan will be negative, but my sine value will be positive. And what we end up with is something similar when we go down into the other quadrants. So if I was to pick another point here, say we pick this point here, I'm still going across -x, but this time I'm going to go down the way. So I will have -y also. So -x and -y. And what that means, if we look at the examples we have here, -x, we've already said, means that cosine is negative. If I have -y, if sine theta is equal to y, then that's going to mean that sine will also be negative. But if we look at tan, tan would be -y over -x, and a minus divided by a minus gives me a plus. So tan would be positive. And again, looking at our cast circle, we should remember that tan is positive in that third quadrant. And the same thing applies then in the fourth quadrant if we want to have a quick look at it. If I was to take another point over here, again going across x but going down -y, I'm drawing in my little angle here, I'm making my triangle in the same way that we've done with all the other examples. What we end up with is that cos theta would be x over 1 and sine theta would be -y. Tan theta would be -y over x. So again, cos being the positive answer in that section. Okay, so it's important that we just kind of have an idea of where this is all coming from, and if we understand where it comes from in the first place with the unit circle, then it should be clear enough to see it for the other quadrants as well. But learning off this here cast circle is very important. Okay, so cast circle starting with the C down here. Some people do Sex and the City, fine as well. So going 1, 2, 3, 4, and that's fine as well. Just making sure that's something that you're going to remember. Okay, remembering as well, I suppose, that if you remember they're all positive here, Okay, and if you understand where it comes from, then that should help you remember that maybe sine is positive in this one. And you can always try it for different angles and see what answer you get. Something that comes up with our unit circle then, more than just the sign of or the yes was the sign, whether it's positive or negative, of our different ratios, is going to be the value. Okay, the value of those different ratios. We're used to looking for the value between 0 and 90 and using our calculator to do so, but sometimes we will want to find the value for angles bigger than 90. Okay, and we can use this unit circle in our cast circle to do that. So as we've said here, the cast circle helps us identify the sign for each ratio, so whether it's positive or negative, but to find the value we use what we call reference angles. And a reference angle is the acute angle to the horizontal x-axis. So the horizontal x-axis, really, really important. And for any angle, the reference angle, so if I have angle A there, for example, sine of A is equal to sine of R, my reference angle. And you can see those two lines there meaning absolute value. So what I mean by that is the actual numerical value will be the same. Whether it's positive or negative depends on what quadrant we're looking at, because we've already established here that sine, for example, is positive in the first and second quadrant, but not in the third or fourth. So it depends on the size of the angle whether my answer is going to be positive or negative, but the numerical value will be the same no matter which of the sections I'm looking in. So how does this kind of come about? Well, if we go back to what we were looking at here, and I very kind of purposefully drew out these particular angles here. So let's just kind of clear up a little bit of this here so we can kind of have a think about what we're looking at. So in these different quadrants, what we did was we took the point P and we were kind of taking a mirror image of that point into each of the four quadrants. So if we were to give them all names, we can call this S and T, maybe, or maybe give them, maybe not S and T because we might be using them, so maybe M and N. Okay, the point M here and the point N, let's just label those again. So we said for this one it's minus X minus Y, and for the point N then it's going to be X minus Y. Okay. So we have our 4 points here. So P, Q, M and N. And they're all mirror images of P. So what we have is that the angle here in the center that I've drawn in each time is the angle theta. So for each of these points, that angle theta to the horizontal axis is exactly the same. Okay. If we were to pick one of our ratios, say we pick cosine, for P, cosine theta is equal to x. For this point Q, cos theta is equal to minus x. For M, cos theta is minus x. And for N, cos theta is just plus x. So what we can see there is that for each of these points, okay, and for each of these angles that we've drawn in, so this angle theta in the center, keeping that angle the same each time, so that's the same size to the horizontal, what we end up with is that cos of theta is either plus or minus x. Okay, the actual numerical value, it's x each time, but whether it's a plus or minus depends on which section we're looking in. Okay, but the numerical value is the same. And when we look at reference angles, we're doing something similar to that. Okay, so we're picking the point that's nearly a mirror image of the one in the first quadrant, and we're seeing how does that cross over with the one in maybe the second or the third or the fourth quadrant. So when we're given an angle, we're going to try and match it up with an angle in the first quadrant, because in the first quadrant we can find out the answers fairly easily, and then we have to see, well, how does it affect the sign? But looking at this example here helps us just to see why the reference angles and the original angles have the same value. It all comes back to these triangles that we've drawn in. That's why it's really important that you use the angle to the horizontal, not maybe the angle to the vertical, the y-axis. So always the angle to the x-axis and marking it in the same way that we've done here. And all the time we're trying to figure out what is the angle in the first quadrant, in this quadrant here, that matches up with one of my angles in the other quadrant. So where it would have the same numerical value, even if it's not sine, where it would have the same numerical value. So looking at our steps for this here, or looking at some examples, if my angle was 60 degrees, then my reference angle would also just be 60 degrees. Okay, so still just be 60 degrees here. Because the angle to the horizontal, let me just make it thicker. Okay, if my angle here was 130 degrees, okay, so 130 degrees, remember all our angles start from here and go the whole way around past 90 all the way to 130 degrees. My reference angle is the angle to the horizontal. That would have the same value as one in the previous section. My reference angle will be 50 degrees. Here again, looking for the angle to the closest horizontal. If my complete angle is 320, my reference angle is going to be 40. That's kind of coming from, there's 360 altogether. I take away my 320, and that gives me a 40 degrees. So in finding our trig ratios for given questions for bigger angles, first thing we do is we'll draw the angle and we'll see what quadrant it's in. That gives us an idea of the sign that we're looking for. Then we're going to find the reference angle or. Okay, then we're going to look for our reference angles. After that, we want to calculate the ratio for our reference angle, and then we're going to add the appropriate sign. So depending what quadrant we're in, we'll have to add in the appropriate sign. So really what we're doing is we draw the angle, see what quadrant we're in, we find the reference angle, we want that angle that we can compare it to from the first quadrant. So we've seen that in our circle that we drew, we've seen that there are maybe 4 different angles that will match up. We're trying to compare it back to the one in the first quadrant. Then we get a ratio for that reference angle, so that will be an angle that's smaller than 90 degrees, and then we add the appropriate sign. Can I turn on the light here? Better. Okay, so let's have a look then and see how that works for us. So if we do the first example here, sine of 120 degrees. So let's have a look. So draw it out first. So a sketch. Doesn't have to be perfect. Got it. Okay, so let's have a look. So we're starting from here. We draw around, we're past 90, and we'll go to about here maybe. And we'll mark it in. So this is about 120 degrees. Okay, round about. It's past 90. And that's all we want. So thinking of what we did originally, if this is kind of my point that I'm at, we can think of my reference angle then as being the angle in here. And what is the size of that angle? Remember, we want to match it back up with a point somewhere along here, so that we can compare, so that we can find our value. My reference angle then is just going to be 180 minus 120, which gives me an answer of 60 degrees. So my reference angle or is 60 degrees. Let's find the answer for 60 degrees then. So sine of 60 degrees is equal to, and we can look at our log tables for this. Our log tables has the value for a lot of these answers, and sometimes the question will instruct you to use your log tables or not to use a calculator, and then you have to go to your log tables and use these values. So if we look at this one, sine of 60 is root 3 over 2. So sine of 60, root 3 over 2. So that means that sine of 120 is also going to be equal to root 3 over 2. And the last thing we need to look at is whether it's positive or negative. And to do that, we think about our cast circle we have here. We look at which quadrant we're in, and we can see here that we're in the second quadrant. And in the second quadrant, sine is positive. So my answer is just plus root 3 over 2, exactly the same as sine of 60. If we do cos of 225, so let's do this one as well. Cos of 225, so I draw it out first. So thinking about this is 180, so I'm going round past 180 to maybe somewhere about there. Okay, so this is about 225. Again, think about it the same way that we've done. It's the angle to the horizontal, to the closest horizontal. So we're going to look for this angle here, this purple angle that I've drawn in. So if I'm going 225 altogether, I'm going to take away 180, and that's going to give me 45 degrees. So this angle here is an angle of 45 degrees. Okay, because if we've gone 225, we just wanted to see how much more than 180 was that. Then we're getting cosine of 45, so cosine of my reference angle. So let me keep maybe in the purple colour. Cosine of 45. And looking at my log tables again for that one, so cosine 45, 1 over root 2. And thus the same answer will apply to cos of 225, and we just need to see about whether it's positive or negative. So we're in the third quadrant this time, and in the third quadrant tan is positive, which means cosine is negative. We mark it in then as a negative value. Now let's look maybe at the fourth example here. Cos of 135. Okay, to do this one, we need to kind of think about what it means. So instead of us starting here and going this way, what we're going to do is we're going to start in the same place, but we're going to go back the way. Okay, this takes me back 90 degrees, so we need to go a little bit further, and we'll mark it in. And this is an angle of minus 135 degrees. Okay, so starting at 0 and going back the way now. And again, we still want to find a reference angle. It's still going to be the angle to the closest horizontal, so it's still this one here. Okay, so I've gone 90 degrees, so let's see, we're approaching, if we were to do 360 minus 135, that would give us an idea of where we've got to, and that's going to get me to, no, what am I doing? That's going to give us too big of an angle. What we want to find is that small angle. So I have 180 degrees altogether in this part here. And if we take away the 135, that'll tell us what our reference angle is going to be. 180 minus 135, and again we just get 45 as our reference angle. Okay, and then we're ending up with the same question we just had. So cos 45 is 1 over root 2, and then cos of minus 135 is equal to minus 1 over root 2, because again it's in that third quadrant where cos is negative. So what we're getting at here is this idea of reference angles. Okay, so making sure that you're comfortable with picking out the reference angle, and we were looking at why or where these reference angles come from when we were going through that example. It's just making sure that you were happy with how you come up with a reference angle, how you work out which angle it is, so it's the closest angle to the horizontal every time, and just making sure then that you can also use your cast circle to decide whether the ratio is going to be positive or negative. Okay, so the two things we've looked at, the cast circle here, whether they're positive or negative, and then kind of exploring this a little bit as well, so where the reference angles come from. But if you know cast circle, and if you know your step for using your reference angles, that's going to be really, really important then when we get on to our trig equations then.